All right, welcome back to Mr. P Helps with Algebra 2. This is Unit 3, Topic 1, SLT number 2, day number 2. And we got, once again, another warm-up that's very similar to what we've been doing. Playground has a radius of 9 and a center height of 17. Now, I'm going to start with all the ones that are the easiest to do. So, like A has a height of 17 because it's the same height as the center. G also does, but that's not one of the choices. D is 17 plus 9, which is 26. I can also do J fairly easy, which is 17 minus 9, which is 8. Now, B, I'm going to have to find the height of this triangle. So that would be the radius, which is 9 times sine of the angle, plus the center height, which was 17. In this case, this is broken up into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different sections. So 360 divided by 12 is 30 degrees per section. So it's 9 times sine of 30 plus the center height, which is 17, and that gives me 21.5 for B. E is this position right here, which would be 30, 60, 90, 120. So I can do 9 times sine of 120 plus the center height. 9 times sine of 120. Now keep in mind, I could have also used 9 times sine of 60 because C has the same height as E. So 30, 60, 90, 120 I chose to use for E, but 30, 60 would have been the exact same thing. Plus the center height, which is 24.8. And that leaves me with H. H is 30, 60, 90, 120, 150, 180. That would be 210. So 9 times sine of 210 plus the center height. 9 times sine of 210 plus the 17 for the center height, which would be 12.5. All right, if it takes 60 seconds for one complete rotation, how long will it take to get to the furthest point? The furthest point is D, so 60 seconds multiplied by 1/4 of a circle. That's pretty easy. 60 divided by 4 is 15. Now, the other logical way of doing that, if it's 60 seconds to go all the way around, then you know it's 30 seconds to go halfway around. And halfway to 30 would be 15. 15, 30, this would be 45. 45 would be the closest because it's every 15 seconds. 15, 30, 45, 60. 60 seconds to get all the way around. All right, answer the following questions about the merry-go-round from the warm-up. How far away from the wall will you be after 75-degree rotation? We're going to use the same formula, so that's 9 times sine of a 75-degree rotation plus the center height, which I believe was 17. Yes, it was. And all I got to do is put that in the calculator. 9 times sine of 75 plus the center height, which gives me 25.7. All right, what other degree of rotation will be the same distance away? Now, this is a good question. So if it's telling me that this is a 75-degree angle, and this over here is also a 75-degree angle, then these 2 points will be the exact same height. But remember, the standard angle is always from the starting position. So if all the way over to here, halfway around the circle is 180 degrees, and I subtract the 75 degrees, then that would be this standard angle. Because I go halfway around, which is 180, go backwards 75. Going backwards means I'm deducting, taking away, and that leaves me with a 105-degree angle. Recall that it takes 60 seconds for one complete rotation. Can you come up with a model? So D of T is equal to the radius, which was 9. Okay, I've actually been using this. Times sine of the, this is the degrees per second. So I use D times T, which is degrees per second. And then you plus the center height. And there you go. All right, put it all together. How high will it be after a 60-degree rotation? So first thing I need to do is find the degrees per second. Oh, actually, no, this is not time. Sorry, Ferris wheel is 40 feet. Radius is 40 feet, and center height is 49. All right, so that's radius times sine of 60 plus the center height. 40 times sine of 60 plus the center height of 49 is 83.6. Is there another rotation that will give you the same height? So that's 180 minus 60, which equals 120. So a 60-degree angle and a 120-degree angle will be exactly the same height. They'll both be about, give or take, right there. So that angle and this angle. So as long as this reference angle and this reference angle are the exact same thing, then these two positions are exactly the same. So if this is theta, then this would be 180 minus theta. Now, if that reference angle was down here in the third quartile, then it would be 180 plus theta, which I believe we do in another video, and this one would be 360 minus theta, because really you're going a full circle minus the same reference angle. Theta just represents whatever that reference angle is. So as long as all of these angles are exactly the same, then these two height positions must be the same, and these two heights must also be the same. If the Ferris wheel makes one complete rotation every 48 seconds, find a model represents the height of... Okay, so I need to figure out the degrees per second. So 360 divided by 48 gives me 7.5 degrees per second. So now it's radius times sine of degrees per second multiplied by t amount of time plus the center height. How many seconds will it take to get to the lowest point? Well, to get to the lowest point, that's 3/4 of the way around the circle. So 48 seconds times 3/4. Let's see, 48 times 3 is 144. Divide that by 4, and you get 36 seconds. How high will you be after 4 seconds? So I can put 4 seconds into our equation and solve. 40 times sine of 7.5 multiplied by 4 seconds plus 49. And that's our answer. 7.5 times 4 plus the 49. Enter. And you get 69 feet high. All right, and I think that is it. So I'm going to stop right there. Thanks again, once again, for watching. If I helped you learn something about trigonometry and using sine to find any positions, heights around a circle. And we are leading ourselves towards graphing sine in the next topic. Thanks again for watching. Have a great day.